Hello. Could someone on the stream just confirm you can hear this? That'd be great. You just put it in the chat. Just want to make sure all the audio is working. Hello. Hello. Hey, everyone. If you could all just start to take your seats, we'll get going in just a second. Great to see so many people here. It's an awesome crowd, possibly our best one yet. So hopefully not too many people have to sit behind the pillars. Feel free to move the chairs out if you want. The boring announcement I always have to do, because people always ask me, where are the loos? They're behind that almost invisible door at the back, the gray one on the gray wall. If you go in there, there are a bunch of them. Yeah, a couple of quick things from me. So firstly, like this wouldn't happen without thanks to my company and I guess our sponsor, Selden. So they help provide the venue and the food and drink and things like that. And they also give me time to work on it. So thanks very much to them. If you haven't heard of Selden, they do machine learning, model deployment, monitoring, and explainability. You can come chat to me, or I see my colleague Rafal's over there as well. So you can go and chat to him, grill him on stuff. That's about it. The only other thing is that I'm always looking for speakers for this, right? I say this every time, but you don't have to be doing something at the forefront of machine learning to be able to come and speak here. Things that are like, individual experiences that you've had, stories, what it was like taking on my first data scientist job. All of those kind of things are really interesting. So if there's anything you do have in the back of your mind that you're particularly proud of, or you'd like to come and talk about, please come and see me afterwards, or I don't know, send me a message on Meetup or LinkedIn. And with that, I'm going to hand over to Andrew Jones from GoCardless, who's going to talk to us about data contracts. So let's welcome him to the stage.
Cool, thanks everyone. Yes, I'm Andrew. I'm from GoCardless. I'm principal engineer there. And I'm going to talk to you today about how we are driving ML data quality with data contracts. So hopefully by the end of this, you'll have a good idea of what data contract is, particularly if you haven't heard it before. Some idea of problems trying to solve by implementing data contracts, and how you might want to roll it out your organization if you want to do that. So just briefly, a bit of context on GoCardless. So we're a fintech based here in London, we operate in many countries around the world. We're building the world's leading bank payment network. Most of our customers use us for recurring payments, so things like gym memberships, energy bills, charity donations. Also, if you're in the UK, you use GoCardless without realising it. You can also make one-off payments via GoCardless. And some of our big customers include people like The Guardian, DocuSign, Klarna, and people like that, although also many smaller customers as well. In terms of like how we're using ML and how we're using data at GoCardless, there's probably like 3 key models we have at the moment. First one is the fraud model. So as you can imagine, being a fintech, being a payments company, people want to defraud us, take money from us. So we try and prevent that. The other 2 are quite interesting as well, because they are both ML-driven products that we offer alongside our core offering in attempt to generate revenue and differentiate ourselves. So the first one is something called Success Plus, which is about retrying payments when they're most likely to succeed if they failed. And Protect Plus is around protecting our merchants from being defrauded. So people will sign up for a membership with no intention to pay, or using stolen details or something like that. And I say these are interesting because they are offerings that we offer alongside our core product. They're data-driven, and they're there to try and really generate revenue and differentiate us in the market. I think that shows how important data is for a company like GoCardless. So it's probably won't be a shock to anyone in the room or online. It turns out data is critical to a model's performance. Right? If you don't understand the data you're using, if you don't have confidence in the data you're using, if you don't trust the data you're using, you can't build an effective model. So where does the data come from that drives these models? Well, this is what the architecture of GoCardless looked like a couple of years ago. And it's probably quite familiar to many of you. You probably have a similar architecture in your organizations. We have a bunch of services, they write data to databases. We just kind of suck that data in. We use a change data capture tool, CDC tool. You might be using some sort of EL tool or ELT tool. And we basically recreate those data sets, those databases inside our data lakehouse, or for us it's BigQuery, it could be Snowflake, it's kind of the same. But we create those data sets for databases exactly as they were in the upstream database. Logically, this is called like an operational data store, if you know that term, but yeah, so it looks identical to the upstream databases. We then do loads of transformation on that data, loads of retail jobs, loads of DBT models, loads of feature pipelines, and eventually transform that into something that's useful in like more logically like data warehouse style database. And it's that data that we use to drive all the things we drive from data, so analytics, models, other services, things like that. And like I say, it's probably familiar to many of you, this kind of architecture. And there are no problems with this, which again will probably be familiar to many of you. First one, probably the most obvious one, the classic one, is that changes upstream negatively impact all the downstream consumers. So the obvious one would be a schema change. Someone changes the schema upstream, your ETL breaks, everything breaks downstream. Obviously, there are more silent failures where the logic changes or the data changes. Maybe you don't notice, maybe you realize the model's performing worse, or maybe your customer notices. Either way, like you have to react to these changes upstream. By the time you notice, it's too late to get that change rolled back. Like the engineers making a change in the service, they made it for a good reason. Maybe they're for maybe it's performance improvement, maybe it's a new requirement, a new feature, whatever it might be. By the time you know about it, it's too late for that to be rolled back. So what you end up doing is you work around in the ETL. You add like another case statement or another worst case, like if day is the day, do this, else do that, all those kind of things. And the more of those you add to ETL, the more complex it gets and the more brittle it gets. So you're further increasing the unreliability of the pipeline as a whole. Another problem with this architecture is it's got this big bottleneck in the middle. While in theory, the data come in the operational data store layer, in theory it's usable, it's just in BigQuery for us. If you can write SQL, you can query it. You've got Looker, you can use Looker to go and look at that. So in theory it's available, but it's not really accessible. Because to use it, you have to know a lot about the upstream services. How do I model the data? How do I do the joins to get the right data, get the data I want? What's the history of that data? How has it changed over time? Is there any kind of backfilling done? How is that done? All that kind of thing. So while it's in theory available, it's not accessible, it's not usable. So what happens is that really the only data that's really being used is data that's in the data warehouse, which is obviously a smaller subset of data. The rest of that data we're not really getting value from. And finally, there's a huge gap between the generators of data and consumers of data. And if you're a data generator, you might not even know you're a data generator. Like you think you're just working on your service, you're changing your database. It's your database, your internal models. You don't know that that change is going to impact loads of people downstream. You don't know it's going to break a key process or a product that we are trying to sell. Meanwhile, if you're a consumer, you're just getting the data you're given. You have very little say over what that data is, how it can be changed, how it can be improved. You just get what you're given. So these are kind of the problems that we have, I think many of us have at GoCardless, and also in the industry. And the root cause of this problem is that the data was not built for consumption. Right? It was built to satisfy the needs of that internal service or that upstream service. It's been modeled in a certain way to meet the needs of that service, that transactional database. It's not been built for analytics. It's not been built to help you build features, do feature engineering on it. It's not been built for consumption. And like I said, like, we have this problem seems to be universal. Like, I used to be in meetings a lot with like data engineers and BI engineers and data scientists, hearing about the problems this was causing, like, all the time. And I speak to people at other companies, and they all got the same sort of problems. And we just started thinking, like, you know, it's the 2020s. Is this really the state of the art? Is there not a better way you should be doing this these days? So what did we actually wanted? Well, we wanted data that was documented, that was usable, but actually accessible. want data that was versioned. Like, we understand data evolves, and that's fine, but every change should not break everything downstream. There should be a way to manage that change. And we want clear expectations so we can build on it with confidence. So what I mean by that is, like, you can't build on data with confidence if you don't know what to expect from data, on the structure of the data, on the SLOs of the data, how reliable it's going to be, who owns it, who generated it, who's on call for it, if anyone. If you don't know what to expect from data, how can you then be confident in what you're building and provide any expectations to your consumers, to your product teams, to your customers in terms of the reliability of the product you built or the model you built? You need to have those upstream if you're going to offer them downstream. And we decided that really this should be the responsibility of data generators. Right, they know most about data, it's their domain, they own the data. They are the only ones who have the ability to change the quality of the data, improve the quality of data. It should be their responsibility to provide data that the rest of the business needs. So we started thinking about how we could maybe do this. And so my background, the last few years, I've been working in sort of data side, sort of data platforms, data engineering. But the first half of my career was more software engineering. And if I was in a software team, I need data from another software team, another service, I would never say, like, can I just access the database directly? I'll be like, okay, I need to access this data. Can you provide an API, an interface, or something like that? We'll talk about it, we'll discuss the requirements, we'll see what they can do, and hopefully I'll bring me an API to query. And they should be able to do that because building APIs isn't particularly hard these days. Why is it different for data? Why is it okay we can depend on the internal models, just chuck our data, or extract our data from databases, chuck it into a warehouse and just hope for the best and think that's going to be reliable, because it's not. So yeah, I thought, why can't we have the same for data? Why can't we have an explicit interface that's been agreed, that's been discussed? Why can't we have something that's fairly stable? Because actually we probably favour stability more than anything. But with the ability to evolve over time as data evolves, as needs evolve as well. And often with an API, it's kind of referred to as a contract. And sometimes it's literally a contract between you and a service provider. And this word contract kind of stuck with us, hence why we called it data contracts. So those are problems that we want to solve. For this next session, I'm going to talk about, like, what exactly is data contracts. Go off a definition, and then there's 4 principles that I believe make up data contracts, about important data contracts. So we'll go through those as well in turn. So this definition I've been refining over the last couple of years or so. And I believe a data contract is an agreed interface between the generators and consumers of data. It sets expectations around data, defines how it should be governed, and facilitates explicit generation of quality data that meets business needs. There's really 4 keywords in there that are highlighted. It's the interface, expectations, governed, and explicit. So those are the 4 principles around data contracts that really underpin data contracts. So we'll go through those next. Starting with interface. I've spoken a lot about interfaces already, but really, think about it, interfaces are the key about any software dependency or any kind of computing dependency. Like, if you think about it, if you're using a library, a Python library, pandas, whatever, there's a public interface you use. And in theory, at least, as the versions change, that shouldn't change. Unless there's a breaking change, and then you know about migration path. Same is true for an API. Same is true if you're trying to build a Slack bot. Interfaces are everywhere. And, like, they're critical, really. So data contracts is an interface. It's stable, supported, it's versioned. You have migration path for new versions, and it's an agreement. And this is quite a key point as well, because this interface, this contract, this definition gives you something that you and your data generators can discuss around and talk around, bringing you a lot closer together. They can start understanding the value you're producing and the problems you're having. Then there's expectations. So this is around documentation, largely, structure, the semantics, schemas, PSLOs, how reliable it's going to be, how timely is the data, what you're promising with the data. Doesn't mean that you have to be offering like 5 nines reliability, but, like, knowing what it is important if you're going to build on it with confidence. Also defining what we mean by the ownership and responsibility of the data, making sure that generators know what they're responsible for, and you, as consumers, know what you're responsible for. Governance, obviously, is not optional these days. There's more and more regulation. There's a lot already. There's more coming. How you handle personal data, if you are handling personal data, how you control access to data. The good news is a lot of this can be automated. They're quite clear policy rules to implement. It's quite easy to do that in code, as long as you know enough about the data. And as we'll see in a few minutes, you could put this metadata in a data contract, and from then on, yeah, it's pretty easy to build the tooling that does the right thing with the data. It shouldn't be a massive headache for data generators. You should automate it away. And finally, explicitness. So obviously, at first diagram I showed, the architecture, we're just sucking data in. It wasn't designed for consumption, like we said. We want to move away from that. We want to be producing accessible data products that meet business needs. And you might be thinking, particularly if you're a data generator, and many people are both, but if you're a data generator, you might be thinking like, well, why should I be doing this? So this is where, if you're a consumer, you need to be good at articulating value, like business value. Why do we need this data? What am I actually going to do with this to really drive business value? So again, it's that conversation, that collaboration. So there are kind of 4 principles of data contracts. And like I just alluded to, if you're a data generator, you might be thinking, well, this is a lot of work. Okay, you convince me of value to understand why I'm doing this, but how am I going to generate data that you want with an interface you want? I don't know how to do that. It sounds like a lot of work. So what I'm going to do next is talk about how we've implemented it at GoCardless in an attempt to make it easy for data generators to generate this data. The implementation is a bit specific to us because we built it on our infrastructure platform. We won't get too hung up on the specifics, exactly what we've chosen to do and how we've chosen to do it. What I'm hoping is that by showing you how we've done it, it kind of illustrates how we are solving problems I spoke about at the start with data contracts. So this is what a data contract looks like at GoCardless, off start of one. And there's more about it on our blog if you want to see it in more detail. It's defined in, it looks like JSON. It's actually called JSONnet, which is like JSON with extensions. Again, that's because that's what our infrastructure platform at GoCardless uses. So everyone's familiar with it. It's kind of a natural choice. If you were going to do data contracts in your own organization and you weren't using JSONnet, I wouldn't necessarily say JSONnet was a good choice, but it's what we're using. In the same way you could use YAML or whatever else. But anyway, data contract has a name, description, owner, version, obviously made up on a number of fields. So this is a schema, so it's got things to spec, name, type, description. They also have metadata around that data. So what data is it? Is it personal data? How do we normalize it when we no longer should be keeping that data? And this is what I alluded to earlier about how you can, if you start collecting some metadata around the data, you can use that to automate a lot of the harder parts of looking after data and managing data, all the governance stuff, all things like that. And then in our data contracts, the generators can decide what resources and services they want around that data. So around Google Cloud, so they want a PubSub topic, they want a BigQuery table. And it's kind of interesting for 2 reasons. One is we think we can build any data tool we want based on this, like through the data contract. So like in future, we can automatically collect SLOs and monitor those and send out alerts when they are breached. Maybe we can automatically generate FO tags or some other orchestration engine that runs the data daily or whatever it is, runs CPU jobs. Maybe we can integrate with reverse ETL tool and get data out to different third-party services while tracking that kind of lineage as well. There's quite a lot we can do with this in future, and we think, and we are pretty confident that we can build anything we want to through data contracts, on top of data contracts as foundation. The second thing that's interesting about this is that we're trying to give generators some flexibility. Like you could choose how, you have the autonomy to choose how you want to provide that data to consumers. Is it more event-driven? Do you want PubSub? Is it more batchy or more data warehouse, more BigQuery? And that sense of autonomy leads to a sense of ownership and accountability and responsibility for that data. Like, it's their data. They decided what schema looks like. They can have it really wide, they can have it really deep. We don't care, as long as they tell us what data looks like in terms of metadata, so we can run tooling against it. They can choose what tooling they use, what interfaces they provide. We don't care. Like, it's their data. It's you have ownership to decide how you want to provide that data to consumers to meet their requirements. And this flexibility has proven quite successful. So nearly a third of contracts don't use PubSub, just BigQuery. Nearly 1 in 10 contracts don't use BigQuery, so they're more event-driven use cases, more service-to-service, maybe more engineering team, not necessarily going to data science or BI or people like that. So yeah, we're finding data contracts being used in a lot of different ways, and this flexibility helps with that. And that's all we have to do as a generator. If you're generating data, all you have to do is define that data contract, that interface. And behind the scenes, a lot happens when you merge that to your main or master branch. We generate we spin up a number of resources on Google Cloud. It's a PubSub topic, that's a schema, so you're doing schema validation at the infra level as well. BigQuery table, matching schema. Those schemas can stay in sync with the data contract as you evolve them. We deploy a bunch of Kubernetes resources in their namespace that kind of hook up these things or do the data handling, do the governance stuff. And all these things are deployed, they're all isolated, they're all per contract, they're all in the Google Cloud project owned by the data generator. It's their resources. If I want to configure it, I can, it's theirs. If I want to give access to it, I can, it's theirs. No central team, no bottleneck, decentralized. But although it's isolated, it's not siloed because we integrate data with a number of central services, like central data catalog, metrics, alerts, dashboards. And we're taking advantage of modern data warehousing, lakehousing tools like BigQuery and Snowflake. With BigQuery and Snowflake, you can query data from wherever it is. Like, there's no penalty for doing that. You're isolating it for ownership reasons, for isolation, for those kind of reasons, but you're not siloing it. I can join data from any of these data sets, bring them back together. So it's decentralized, but not siloed. What we end up with at a high level is like an architecture that looks a bit more like this. So each of these services are writing directly to the kind of own area of data warehouse. The data contracts is the interface. All these sort of data products, if you like, they're all associated with a certain domain. And they're useful on their own. Anyone can go and query them. You can start building features on them. You can use them for drive analytics or internal services. Anyone in business can understand them because they're good quality data sets. We still obviously have BI working. They bring the expertise to joining different data sets, joining different domains, building sort of high-level data sets, and again, providing that to anyone who needs them through a data contract. At the platform level, we don't really care how we're generating data. It could be DBT, could be Python or Ruby or Go script somewhere. It could be anything. We don't care. What we care about is what's the context of our data, what's the expectations of our data, what's the interface of getting that data, who owns that data, etc. And all of that is in the data contract. So that's a very quick tour of how we implement data contracts and how we try to use. We have an implementation that tries to drive certain things we want to change in our organization. That's why, like, when it comes to data contracts, I have to say, like, it's not really about the implementation. Like, it's interesting, particularly if you're quite techy, like I am. But, like, really, with data contracts, we have implementations designed the way it is because we want to drive change in the organization. I think that's when it becomes more powerful. We're using data contracts to try and change our data culture. We try and move away from this data exhaust, this byproduct data, and building on that and building on internal databases to something where we're deliberately producing data as a product that meets requirements. Trying to bridge that gap between consumers and generators of data. We have a lot more collaboration. We want generators to know that, the data I'm producing helps improve fraud model and reduce fraud by X%, that saves millions of pounds. That is something they should feel proud of. They're helping the organisation achieve goals. Really encouraging that collaboration through the way we design data contracts. And through all of this, we're trying to move towards becoming like a real data-driven organisation, one that drives a lot of business value through its data. Because we believe, or we know, our data has value, and so we guarantee it with a data contract. And that's all I've got. So I've got a plug. But thanks for listening. I hope you found it interesting. If you want to know loads more about this, I happen to be writing a book about it, which is available soon. You can pre-order it now. If you don't want to pay for anything, you can read my free blog posts about it on Medium. You can always get in touch with me on LinkedIn or after this, obviously. Happy to chat about it more. And you can learn about GoCardless on GoCardless.com. So thank you very much.
Just a quick question from the stream before we go to the room. So someone's asked about how do you handle personally identifiable information, and I guess any other sensitive stuff?
Yeah, so with that, we make sure it's tagged with metadata, like I showed. So that's the responsibility of data generators. And then we have a data infrastructure team, or data platform team. We have implemented tooling that uses that metadata, uses events from our privacy tooling to go and anonymize data when we have to for GDPR request, or when it's we no longer should have that data because it's either a retention period. So we've tried to take care of that centrally by deploying the tooling. As a data generator, you don't have to become an expert in GDPR, you just have to tell us about your data.
Cool, thank you. Right, I'll do questions in the room. Just raise your hand if you have one, and I'll bring the mic up. Make sure you do it to the mic so people online can hear.
Thanks. Just a question about, so like to my understanding, proto buffs and things like that with RPC do kind of a lot of this just out of the box by definition. So I'm just curious as to where you would see, maybe it's more in like the specifics of the implementation level, but where you would see maybe a comparison of this compared to using something just like proto buffs out of the box that handle a lot of the schemas and language agnosticism and things like that.
Yeah, it's a good question. So the data contract I showed, that definition, that's custom, so we can collect more than we can collect in like a protobuf or JSON schema or whatever. But we take that, we convert it into many different formats. So we convert it into protobuf because protobuf happens to be how you configure Google PubSub schemas. We convert it into a custom JSON to configure BigQuery tables. We convert it into JSON schema, which is used by our Ruby applications, so they can do data validation locally before sending it to PubSub eventually. So we see it's like we will leverage read open tooling as much as we can by generating it from the data contract, from this kind of high level definition.
Where in the deployment process do things blow up if you've made a mistake in a data contract, or the data contract is highlighting a problem with the schema?
Okay, where things blow up. So there are validation checks when you create data contracts. So if you say it's personal data, but you haven't told us how to anonymize it, it will say no. If you're making a schema change, if it's a breaking schema change, and you haven't created a new version, it will say no. Kind of have a CI checks before you can merge to master. And then once it's deployed, like I mentioned, we're using PubSub schemas. So if you try and write something that's not matching schema to PubSub, it will say no, and you'll get an exception. I mean, it's up to you how you handle it, but we've got patterns around using dead-left queues and things like that. And then, like I said, we generate JSON schema documents that's got added validation in it. So if you're doing local validation, you can also check there and again catch it. So it's kind of various layers, really. The contract itself is mostly CI checks. In production, it's mostly schema checking at various layers, infrastructure layer, and higher layers where we can do a bit more work as well.
Thank you so much. I really like that in your explicitness principle, you mentioned incentivizing data generators and operational data generators to adopt this. That's something that I find really hard. I'm very bought into the idea, but I struggle to work out what the first step is. How do I what's my first step in bringing this about? in a big organization?
Yeah, it certainly is the hardest part, I would say. Or it's for sure, it's the hardest part. The implementation was relatively easy. We spoke out in a few weeks, built on it, iterated on it. But yeah, getting that buy-in, getting generators incentivized, that's for sure the hardest part. But I did that. I spoke to a lot of generators before I even worked out what it's going to look like and things like that. Engaged with a lot of tech leads, a lot of sort of staff plus engineers, people like that. And what I find is once they understand the problem, that if it's caused on the data of consumers, and the trouble it causes on business goals, basically, what the actual outcome is, they actually were they were quite happy to do it all work. Really, it wasn't. I understood why. I understood, particularly when you're using Analogy to an API. If you're talking to engineers using Analogy to an API, it's obvious for them. I understand why. We built tooling in a way with their collaboration. So one of the reasons we don't use Protobuf, for example, at the sort of transit layer, we use JSON because we're using Ruby a lot in-house, and Ruby and Protobuf don't work very well together. So we try to solve some of those things. Actually, we're solving as well some of their problems, like engineering teams consume from other engineering teams, consume data, particularly as we GoCardless to move into a more event-driven model from a monolith anyway. So they understand, I consume data I consume banking event data. I'm not BR, I'm not a data scientist, but I need that to go and populate a building platform. I want data to be reliable. I want a schema around it. I want documentation too. So they understand it as well. So that's on the engineers, the actual engineering team side. You then have a question about making it a priority in terms of product priorities. And that's where it gets harder again, because now you're competing against product features and things like that. Again, all you can really do really is be good at articulating the value you're trying to provide with this data. I think that's something that, I've had to learn. A lot of people had to learn. Often we assume data's going to be valuable, I think, but you kind of have to prove it in advance, or at least be able to articulate that to people who don't know data, people who are not in this room. And it's a skill we had to learn. I had a good product manager, she really helped. But yeah, it's certainly the hardest part.
That makes a lot of sense. Thank you very much.
Sure. 2 questions. First of all, though, thank you. Congratulations on an idea that spread so globally, so quickly, and is actually useful for the data community versus a lot of the other stuff I see on LinkedIn. Question 1 is, for data producers, that on your diagram, you had the word validate just before the GitHub icon logo. What's the quickest validate piece of code or script out there to get data producers to get going with some sort of validation process from a data contract? 1. And then the second question is, if I'm consuming from Salesforce, who I presume don't use data contracts, what's your recommendation for dealing with external service providers like CRM systems that are probably not going to do this for a very long time, or they'll have their own Tableau version that's not very good?
Yeah, that's good questions. First one, I guess the quickest way to get started with that contract, really, and we used to say this before you even write the code, was just start a document, start a spreadsheet, and say this is what we agree, and start having conversations, because that's one of the first steps, is to have conversations about what the consumers expect, what their requirements, what generators can provide, and then probably the quickest way to code it will be, I don't know, use Protobuf or something, using something like that, using an open source thing. But people are building open source tools now that look a lot like data contracts. Or you can use observability platforms, sometimes have support for schemas, so you can use it in those kind of things if you've got one of those. But more of these observability platforms are building data contract-like things, so we can sort of put data contract in and validate it there. But it's not ideal, I would say, because you're doing it late, so data's already been in flight, and you're kind of reacting to it, which is much the same as what you have without data contracts. You just know about it a bit sooner, but at least you're having a conversation. You're starting to have those conversations. What if you want to do it in CI checks? Yeah, use Protobuf or Avro or whatever. Second question was Salesforce, third-party services. Yes, that's a really good question. We want to tackle third-party services at some point. We haven't got to it yet. And yeah, the problem obviously there is we can't put our code there. We can't get Salesforce to write their contracts. But 2 approaches I think we can take. What I've described is basically generator-owned data contracts. So generator owns it, they provide it like an API. They own it, and they are providing it to their consumers. The opposite of that is a consumer-driven contracts, which has been in software for a while. Some of you might know Pact.io. Might have Flowers written about it. And that's where, again, you're doing it a bit later, but you're a consumer, you're writing the contracts, and then something's validating it as early as you can, like for Salesforce, and then throwing some exceptions. But again, you're doing that quite late, so when you know about it, you can't do much. You just know sooner. You can't really change the data Salesforce is providing. Second approach, I have this question from a company who are a Atlassian kind of reseller integrator. People build like Atlassian plugins. And they're like, well, a big Atlassian partner, but their APIs are horrible and they keep giving us bad data. And I was chatting to this person like after one of these kind of chats. But they're like, well, you've got an agreement with Atlassian, you've got a contract with them, like a legal contract. That says things about like uptime of the APIs, credits if it goes down for too long, things like that. It could also cover the data and make sure the data is reliable and the data is documented. There's no reason why it couldn't. If that's important to you and your business, no reason why you can't try and have those conversations. So that's another approach as well.
All right, we'll do anyone else in the room? We've got time for one more question. Cool, yeah, just at the front here.
Thank you. I'm quite new to ML, so this might be a novice question. But my experience with APIs and sort of accessing data to perform my ML is oftentimes I have to sort of convert the data. Sometimes the data is erroneous, and I have to sort of correct it. And I was wondering, it's just a one-way street. And I was wondering if maybe in the future there might be more sort of collaborative approach to generating data. So I would have a large collection of corrected data, but I'd always have to sort of re-correct it every single time I get the data from the the data source. And I'm wondering if maybe everybody in this room is creating more data. That might be more correct or advanced or whatever. And I'm just wondering if data contracts might be able to, any thoughts on that? So making it more of a two-way street.
Yeah, so I think it's about that collaboration. So it's about that conversation. I think it's the best place to start. I mean, like I mentioned, there are consumer-driven contracts where you can kind of say, oh, I've gone through the data, I've noticed that oftentimes it's between 0 and 1, but sometimes it's 7, and I want that to be part of the contract, and I'll put it in my contract, and I'm applying my contract to your data. Can you fix the data, please? This is what I want. I'm telling you what I want, and this is how it's broken, and this is what I want. And the whole conversation between consumer and generator is an interesting one, because I think if you, as a consumer, are creating contracts against someone else's data, you can't go and fix that data. You haven't got the ability to do that. Very people can as data generator. So, like, say you create this contract. It's the same, like, again, if you're using a data observability tool, you can create as many rules as you like. You get alerted when it breaks. What do you do then? You have to have a conversation with data generators. And ideally, you want it's to come too late by then. The error's happened. Your pipeline's probably broken. Or you've added more code into the pipeline that says if over 1, change it to 7, or the other way around. So yeah, it's really about this conversation. I personally think it has to be ultimately owned by a data generator. They're the only ones who can change the data. They're the only ones who have the ability to do so. They're the only ones who know why it might be 7 today and not 1. So it has to be a conversation, I think.
If enough number of your customers sort of provide that, statistically, it's likely that this is more correct. I'm thinking that might be where one.
Okay, yeah, that makes sense. Yeah, so because you use data as an ML kind of or a data prediction, you've got these kind of tooling to kind of do that kind of sampling data and say, hey, I've noticed. The train may not even know. But then again, yeah, so you go back to them and you have a conversation again. Like, one thing we found at GoCardless is like our data consumers rarely, if ever, spoke to data generators. If I know these problems, if I see these problems and I break their pipelines, I'll be like, oh, okay, I'll just add another case statement here. I'll just deduce something over here. I'll just throw this bit of data away. I never went back to tell data generators, like, hang on, like, this string is normally between 0 and 20 characters long, and now it's 144, and I was expecting not to be, and it's broken, I think. If I just say, oh, we truncate it, and we never have a conversation. And we found actually that it's kind of a skill we had to learn. Like, yeah, you are allowed to have this conversation. They do care. If you can explain to them why, they will care. I don't want to make your life hard. They just don't know they're doing it. So really, yeah, one of the goals of data contracts war is try and increase that collaboration, bring them close together, have those conversations. Generally, maybe I'm not optimistic, maybe I'm naive, but get them talking together and a solution will come.
Great. Okay, so if you still have questions for Andrew, which I'm sure lots of you do, you can find him in the break and afterwards. Let's all give him another big round of applause. That was a really good talk. Unfortunately, our next speaker for today, Shee has actually had a family emergency and is unable to be here. I could present you with two options, essentially. Right? One of them is that you can watch me do a talk that I did at a conference fairly recently, which is about optimizing inference for Python models. I promise you, I'm not going to try and sell you anything from Selvin. It's all open source based. Or alternatively, right, because I don't want to force that down anyone's throats, we can just have more networking time. So what do people want? Let's maybe just do, I don't know, show of hands, right? Who wants another talk? Okay, and who would prefer more networking time? Oh, okay, I'm going to have to do a talk now. Either way, we'll have a short break for 5 or 10 minutes. There's still some food I can see in there, so go and grab some if you only got here recently. And I'll see you back in about 5 or 10 minutes.
This one actually has to be.
Sorry. Hopefully, I'll reach out to you. Just a quick announcement, by the way. The next one of these is happening on Tuesday, the 18th of July. So it's not on Meetup yet, but mark it down in your diaries and bookmark it and come along again. Just nailing down the last couple of speakers for that, and then we're good to go. And when people get their seats, we'll get going again in a second. I might have to do my thing where I go around and herd people. All right, people online, I'll be right back. Okay, right. I'm gonna get going, and people can just kind of trickle in as we get going. No, that's fine. Yeah, all good. People online, I apologize. I've never streamed this at the same time as actually presenting, so this be interesting to see how it works. Let me just give it 1 second. Hang on. Hello. Hey, everyone. If I could ask you all just to take your seats, please. I appreciate everyone wants to chat. I'll make this really quick, and then there's plenty of time afterwards. But there were lots of people who wanted to see a second talk, so I'll try and go through the main points quickly, and then we'll have loads of time afterwards for people to hang out. Okay, so where was I? Right, so yeah, this a talk I gave for a conference called AI at Scale. It was run by the AI Infrastructure Alliance. Something I wanted to talk about was, well, I should probably cross out the state of the art there, because you'll see the model I'm going to use as an example is not very state of the art, but you have to use your imagination and infer that you could use a really large model if you wanted to. Thank you. There we go. It's a good sign, right, when people are so engrossed in conversation with like-minded people that they haven't even noticed that the talk started. So good, but thanks for the help. Okay, so what's the motivation for this? Well, a couple of things. I'll go over what we'll cover quickly. So challenges of building your own servers and why I think you shouldn't do it. An open source alternative, there are others. We can talk about those too. Serving state-of-the-art models. This is a bit where the example is not going to be very state-of-the-art, right? Particularly right now when you've got things like GPT-4 you can use, but you can use your imagination there. And there's some techniques to reduce infrastructure usage and latency and so on. And then we'll finally cover a little bit about how you get stuff into production at the end. The motivation for this is and maybe this is my opinion, but I feel like it should, I don't know. Yeah, I feel like it's right. It's don't be this guy, right? Everyone thinks when they first start learning machine learning, it's oh, well, how do I make it accessible? Oh, I need an API. Oh, well, I'm good at Python. I'll just use Flask or Fast API or something, and I'll write my own API. And there's nothing wrong with that, and you can get something up and running pretty quickly. But it's not hugely scalable as your team grows and your infrastructure usage and the number of models that you deploy. So some of the challenges that you'll face if you take that approach of trying to build everything manually is how do I maximize the infrastructure usage? Typically, each one of these is going to get built into its own container and then allocated its own resources. There's not very much sharing going on at all there, right? A lot of those models might be sitting idle. Dependency management can become a bit of a headache. Probably some poor person on the team ends up being your kind of MLOps/DevOps guru who handles all the CI/CD and sorts all of that out for you. Working with multiple ML frameworks, it's fine if you work in one thing only, right? If you're Facebook and its PyTorch through and through. But if you want to use different libraries and frameworks from different people in the team, that becomes really hard to like deploy in the same way. And then the API definitions for those. So actually, you heard from Andrew about how important it is to define those like data contracts. It's still the same thing when your downstream engineers want to consume an API with an ML model behind it, right? How do we standardize that for them? If everyone's writing their own routes with Flask, like this one is on /predict. Well, what if Andrew writes one on /infer? Like both very reasonable routes to have for prediction, but that's a headache for someone who's got to use both of them. And then, how do we capture payload structures and handle things like multiple versions of models? So the thing I'm going to show you today is MLServer. It's a fully, in fact, I have a slide on it, a fully open source inference server for machine learning models. And essentially what it does is takes your model and serves it under a nice REST and gRPC interface. Supports a whole bunch of popular libraries. You see things like scikit-learn, et cetera. And then I'll show you some of the Hugging Face integration we have as well. Okay, so how do I serve things through this? I'll actually show you this in a live demo because it's a bit more exciting. But there are two files, essentially, I need to work with MLServer. There's a settings.json. You don't actually have to provide this, but these are server settings, right? And then the model settings, which is, this is a configuration that tells me how do I work with a specific model. Okay, you'll see what that actually looks like in a demo in a second. The first thing I wanted to show, which is a way that you can kind of help like optimize the infrastructure usage over just maybe containerizing a Flask app, right, is to be able to do multi-model serving. So if I have 5 different models and I want to run them all on the same infrastructure, with MLServer, you can have them all run under the same engine underneath. So this is essentially a nice little diagram of it, right? And under single model serving, you end up with this kind of overhead of these kind of unused resources. There are also, things like frameworks. If let's say you've got like lightweight TensorFlow models, TensorFlow itself is pretty large and like resource intensive, and the model might only be a fraction of that, right? If you can share that library across, let's say 5, 10, 15 models, right, you can get really good savings on the infrastructure there. And then so multi-model serving does is you kind of put them all within the same inference server, and in theory you can save infrastructure. I'll show you this stuff live, which could go wrong, but we'll see. And it should make a bit more sense. So hang on, let me make this a bit bigger. Maybe that's too big. Okay, so let's see what I've got in here first. Oh, that's small. Again, bigger. Okay, so that model settings thing I mentioned earlier, in here, what we're going to do is serve, in fact, I'm not even going to do this. Before I do this, I'm going to show you like training the model. So what model are we dealing with? This is a really simple scikit-learn model. Any of you who've taken like the first course in machine learning would have done scikit-learn, train yourself like a support vector machine and use some sort of generic data set like fashion MNIST, or the iris flowers that seem to pop up all over the place. This one, as you can see, trains that classifier. And then importantly, what we're doing is we're just saving that to disk as this fashion MNIST.joblib file. Right, so a lot of people in the room should be familiar with this. The reason that's important is because to tell MLServer how to turn this into an API, I need to tell it a little bit about the model. Right, the first thing I need to do is just give it a name. So you can see that up here at the top. And then there's this implementation thing. So out of the box, it can serve a whole bunch of different libraries like scikit-learn. And what I can do is give it this implementation. Basically, I'm telling it this is a scikit-learn model. And then I give it a couple of parameters like the version of the model and then the actual path to my model file. And that's basically all I need. So having done that, I can go in here and just do MLServer start, right? And that, you can see, is now loaded my fashion sklearn model. So let's send a prediction just to check, right, what that actually looks like. Before I do, I'll show you what the test code looks like. Again, very simple. we're going to build up an inference request, and then we're just going to send it to this is all running on my local machine. So it's going to send it to this fashion sklearn model, and we should get a prediction back, right? So here we go. And let's make that a bit more readable. And there you go. So we got a prediction back. We can see that the data here was classification 0. If anyone knows their fashion MNIST super well, you might be able to tell me whether that's a top or a item of underwear. I don't know. Like, as you can tell, I don't know fashion MNIST as well as some people in the room. But that shows you like how quickly you can build a simple API, right? I didn't have to write any of the routes for that. I just gave a little bit of information to MLServer and said, go and run it. Now, what was actually showing here, if you were astute, you noticed it says multi-model serving, not just serve a single model. So let's say, I don't know, in my very basic machine learning startup where we're doing scikit-learn fashion MNIST models, I think, ooh, tell you what, XGBoost is pretty cool. I wonder if I get better results by using that. So I end up with this XGBoost model instead. Let's just navigate in there, and then we can do the same thing, and let's we can have a look at this too. And we'll see, similar thing. In fact, what I'm showing here now is this fashionmnist.json object that was created by the XGBoost model. And I've changed the implementation here to XGBoost, right? And that's all that MLServer needs to know to be able to run it. If we look at the training for this model, again, you'll see it's very similar to the scikit-learn one, but we're just doing an XGBoost train down here and giving it a bunch of parameters, right? So slightly more sophisticated model with potentially a slightly more performant library. Let's see. Okay, so now how do we serve that, right? So jump back down here. Same thing. We just go MLServer start, and we should, when that loads in a second, there we go. We should be able to run another test against this and see, okay, cool. Right, so both of the models are working, but I've served them individually. So how do I do them both at once, right? Well, the cool thing with MLServer is that basically if whatever directory you give it, it's going to recursively search through it and look for models that it can serve. So if hang on, let me just clear some of this mess so you can see. You look on this left-hand side here. So this is the structure of my directory. And you can see I've got this models folder, and in there are two. There's the scikit-learn and XGBoost one. Each of those has their own model settings, which told it how to serve each of them or which implementation it needed, and where the model file was, which was this one and this one. I've actually also got the data set in there, but it doesn't really need it. That's just being used to run those test scripts. But then from here, right, if I do the same, did I spell that right? Yeah, just typed MLServer too many times. Start in here, what you should see is it will actually load both of them. So if you look, sorry, it's a bit big on this screen, but it's loaded fashion sklearn up here, and it's loaded fashion XGBoost down here as well, right? And then if I go and run maybe a quick little like test, I think I've got this test script. Here we go. So test models, right? What this script's going to do is it's actually going to fire some predictions to both of them at the same time and say, oh, okay. And in this case, it's only 10 examples. So it's going to figure out a very, very crappy accuracy for them. But you can see my XGBoost one is better. Great. So it was worth doing that work. Okay, so that was very simple, but it shows you how you can serve a model and how you can serve multiple ones at the same time with the same inference server. Now onto some of the kind of techniques you can use with MLServer or other similar open source inference engines that allow you to kind of optimize the infrastructure. So the first of these is parallel inference. And actually, you might have seen some of this in action already, right? If you look at how it's loaded in, it's gone like loaded twice. What it's done here is it's actually spun up 2 different Python processes and served my model essentially twice, right? And what we're trying to do here is overcome the inherently single-threaded nature of Python, where what often happens is, you've got like multiple cores that you can access, but there's only one sitting there trying to process all the requests. What MLServer can do is it can essentially load your model onto bunches of different workers, different Python processes, and then it dispatches the requests as they come into different ones, and then responds accordingly when they're processed, right? So that is the kind of first technique we're going to look at. The second is called adaptive batching, right? I don't know why I put the demo slide before I do the actual explanation of it. But with that in mind, let's go to the demo, because actually what I'm going to do is is it in this folder, I think? Yeah. Okay. Just going to go here and change my Conda environment. Oh, what did I do wrong there? Did I spell that wrong? Oh, yeah, I didn't. Yeah, just there we go. Thank you. The pressure of being on stage at very late notice. Cool. Right. So we got these. Let's clear all this old stuff out. Okay. The first thing I'm going to do is just load this model without telling you anything about what's happening. The reason will become clear in a minute. Okay. And then let's actually look at what's in here. Okay. So before I explain adaptive batching, which was kind of the point of this bit, let's look at, oh, you go away. You're not supposed to be in here yet. Okay, the actual model. So one of the things I mentioned was we have this Hugging Face runtime integration. Now, what's really cool about that is you actually don't have to provide any Python code at all or any model artifact, right? You can just tell it under these extra parameters, what's the task you want to do and what's the pre-trained model from Hugging Face Hub, and MLServer will go and pull the model down, load it, and serve it out under an API within your MLServer instance, which is pretty neat. So in this case, you can see this is where my joke about not being very state-of-the-art. If you notice, the model here is the distilled GPT-2, which we'll test in a second, and you'll see how far natural language processing has come in the last year or two. But I'm asking it to basically generate text, right? This could be any model on there, right? So if I wanted to load a 60 billion parameter model from Hugging Face, I could do that. I'm going to specify as well, one of the other things I'm giving in my model settings here is this device 0. So I'm saying use my GPU. The GPU on this machine is pretty rubbish, but it's better than CPU. So, and then there's an optional parameter for batch size. And the reason I started that before I explained what was happening was because it takes like a minute or so to load that model into memory. But you can see it's now loaded my transformer model. Okay, before I explain adaptive batching, let's just try and run a prediction. So did I have I think I had a test file in here. Yeah, send inference request. Okay, so this one is going to send the data MLOps London is, and it's going to ask me to just basically like generate some more tokens on the back of that. Let's see how well GPT-2 performs. What was it called? Send inference request. There we go. Oh, hang on. Let's do that again. Okay. MLOps London is underway to address the needs of the government over the weekend via Twitter. New line, new line, new line, new line, new line. Okay. Let's try another one. Okay, we don't have so many new lines, which is good. MLOps London is one of the first to become involved with the development of a service called DataS. The company is launching its own services and can be used for everything on a single platform, but on the London-based company's network. It's very confusing. You can see that, I mean, it's somewhat legible, but it's pretty gibberish. There you go. That's your example of how much better GPT-4 is now, right, than GPT-2. But the cool thing here is that this is all running on my machine. Now, the thing I wanted to show you was with these kind of models, what is another technique we can do that will optimize the infrastructure usage. So what I can do, in fact, I'm going to show you this first, because again, it will take a second. I'm just going to run this, what's it called, load. Okay, I'm just going to run this and then explain what's happening. Okay, so the way, I'll explain it first, then show. So what I've done here is I've basically just sent this, my load.txt, has a little command in there that's going to fire a load test at my model and basically send tons and tons of generation predictions to it and say, here's some text, generate me some more. But it's sending loads of them, and I'm seeing how my model holds up. And what you'll see as the results come back, here you go, it's still struggling away on the left-hand side, is that, I'm going to do this on here actually so you can see, is that I sent 150 requests up here. 79% of them were successful, but it took 33 seconds. And that's presumably, so basically there's like a 30-second timeout. So the kind of last 30% of that batch just never got processed and then timed out. Now, the problem that's happening here is that all of these requests are being sent one at a time. This is basically simulating having loads of users on your system all asking for lots of different predictions. Now, the problem is the way that machine learning models make predictions is not necessarily the best on a batch size of 1. So within MLServer, we can do something called adaptive batching. Now, what's that? Right, here's a nice little diagram. Essentially, it's a way of grouping requests together as they come in, creating a single batched payload with all of those in, then running inference on those, and then unbatching them on the other side and then returning them to the individual users. So if everyone in this room all sent a request at the same time to the API, we'd all get batched together, and then it would do the prediction on a batch and then return it back to us, all our individual component of that. And now that's really neat, right? Because we know machine learning models are pretty good at doing inference on batches, and the performance is way better than if we try and do lots and lots of single batch size 1 predictions. So let's see what that looks like if we turn it on, right? And this is where I have to go back up here to my model settings and say, okay, so if I add a couple of different things to this to enable it, so I can specify 2 parameters here. The first is the max batch size. So this is saying what's the maximum number of requests that you want me to group together in one chunk to send to the server. And then the second one is maximum batch time, right? Because in theory, if I've asked for 128, but I only get 10 requests per second, I don't want my users to have to wait 13 seconds to get their response. So I can also have this maximum batch time, which will take however many requests it's received within. In this case, this is 1 second. And if I enable that and then go in, I have to reload my model. And this will take a second. This is where you can try and practice this for a while, because normally I'd load the model, then go and explain how this works, then come back. But right now I'm left standing here rambling on a stage whilst we wait for it to load. Come on. There we go. Okay, so we've loaded my transformer model. And then let's run that exact same thing. And what you'll actually see down the left-hand side, you can see these requests are coming in much faster. It's kind of a bit, I don't know, this text is almost too large here. How do I make it smaller? There you go. You can almost see the batches coming in as they happen. And if we look at the results for this one, we can see we still sent 150 requests, but the whole thing only took 6.8 seconds. 100% of them down here succeeded. And yeah, there we go, right? So a huge improvement on our previous response. And what the key thing here is I've changed nothing about the model itself. All this is handled within MLServer in terms of just tweaking a couple of settings in the model settings file. So there you go. That's adaptive batching, a very kind of clever technique you can use to optimize inference. Final couple of things you can do with MLServer. So you can build to a Docker image really easily. It abstracts a lot of the building a Docker file and stuff like that. You can just use this MLServer build command and give it a tag. And then once you've done that, if you want to deploy it to Kubernetes, we have another open source thing called Seldon Core, where you can write these lovely bits of YAML and deploy your model as a production API on there. In conclusion, hopefully I didn't take too much of your time. So don't build an inference server unless you have to, right? Don't be that person I mentioned at the beginning. Even though it's tempting because it's really easy at first, what you're just going to end up like with all these headaches further down the line, and you're going to be like, well, implementing adaptive patching yourself and writing all your code for that. And it's already been done, right? We've done it at Seldon. That's what we do as a company. There are things like Triton Inference Server from NVIDIA. Again, reuse someone else's hard work in this space. Multi-model serving can help you serve on infrastructure costs. Adaptive patching can improve performance, as you've seen here. And then when it gets to production, obviously don't run it on your crappy 1650 GPU on your device in a room. Use a proper orchestration framework in production. And that was it, basically. So hopefully that all made a bit of sense. And not at all what you signed up for, but hopefully you learned something. Does anyone have questions? I've got a mic here. I've got my lovely assistant here, Rafael, who's going to bring it. I've got to unmute that as well. I'm really juggling every possible thing I could be doing right now. Okay, it's on now.
It is on? Anyone?
Yeah, any questions?
So I saw that Hugging Face had some like new models, which I can't remember what it was called, but you could do like text to image and all different things like that. Does this naturally adapt to it because it's pulling from Hugging Face, or does the change need to be made?
Okay, good. The question is probably more about the implementation of the Hugging Face runtime. So what you're seeing in here is this bit here, this like task. This needs to be a Hugging Face pipeline, right? And so the model that you choose in this pre-trained model needs to be compatible with that Hugging Face pipeline. So this is for the out-of-the-box ones. Something I didn't mention is that, and actually one of the most popular ways people use MLServer is that there's this custom Python wrapper where you just inherit this ML model class and then write all your own logic into that. And then you can still do the same thing where you go like MLServer start and it just runs it as though it was like, the Hugging Face runtime or the scikit-learn one or whatever, but it's your own custom one. And that allows you to do all sorts of, custom logic in there. So if your Hugging Face model doesn't support one of those pre-canned task pipelines that they have, then you will need to wrap it yourself, essentially.
Thank you.
Yeah, any more questions?
So you showed if you have, like for better utilization of hardware, you deployed multiple models on the same server. If the model size is very large, for example, there is a large language model, can we use multiple GPUs to like shard my model?
Yeah, it's one of those things where it, like using something like MLServer, that the way that you do it, so yes, you can do it, but the way you do it, you need to do handle within your own Python logic, within, as I mentioned, that kind of wrapped ML model class. So it's not something it does out of the box where you can go like, here are loads of GPUs, go and split my model across lots of them. Yeah, any other questions? It keeps ignoring you, but it's fine. You're well positioned for when we stop.
I hope this isn't an obvious question, but the first thing that came to mind is how would you handle continuous deployment in that context? If one of my models needs to be updated, or I have a deployment strategy for that model, but the others don't, do I have to redeploy everything, or is there an API where I can sort of patch things and put things online and take it?
Yeah, very, very good question. So this bit here I mentioned, here on the left-hand side, this framework Seldon core, that is the bit that like adds another layer of orchestration over the top. So MLServer is the kind of engine that runs the models. What Seldon core does is like run those across an entire cluster, keep them online, etc. And actually, recently we released version 2 of that, and it's all been rebuilt around exactly what you asked for, which is being able to load models on and off servers dynamically. So you can have, I don't know, for simplicity, let's say you've only got one MLServer running there with 5 models on it. You can load one off, you can load another one on, you can load a version 2 of one of the models as a shadow or do some A/B testing, that kind of thing before you promote it. You can do all of those kind of things, but you need an extra layer over the top, which is the Selden core orchestration there. Cool. We'd maybe do one more question, and then I'll let people go back to the great conversations they were having earlier.
Thanks. I had a question around Python dependency management. So I noticed with the first set of models that you deployed, they were specifically CPU bound, and I'm assuming that they were operating in the same Python environment. So I was curious around what happens if they had, say, a slightly different version of transformers or something like that. And then also with the Hugging Face implementation you had after, a lot of kind of personally what I've seen is people doing specific things either end of like pre or post processing, for example. So using a default pipeline from Hugging Face isn't that conventional, and especially with dependencies, one version of transformers to another is you can do a lot more with like Stable Diffusion, for example. So just curious about how much you actually have to rebuild out of the box. So for batching, for example, you said use a pre-made solution, don't do it yourself. But how much do you actually have to do yourself with batching, with tensors and things like that, if you do have to change anything?
Yeah, good questions. So the first one is more around this bit, like the parallel inference and multi-model serving. So in fact, this is probably the best one to have up. The question was like, if you have slightly different versions of, let's say, TensorFlow running or something, then does it do anything clever around that? The answer to that is like, well, yes, you can load them both, but what you don't get is the benefit of like shared resources. So we'd still do have to run both TensorFlow versions essentially within this. So this diagram here, you'll kind of actually call this one overheads rather than unused resources, right? Your overheads become slightly bigger because you're packing multiple versions of things in. And the way it does that is, again, like this. Each of those slightly different environments gets spun into a different worker. So they're not. So still on the same server, but as a separate Python process underneath, because that's the only way we can handle the dependencies across those. The second question was around Hugging Face and like custom implementations. The way the adaptive batching works is like at an entry point level to the MLServer, like inference server. So even if you write your own custom logic underneath, you can still enable the adaptive batching because it happens at a request level. As long as your pipeline underneath, whether it's custom or a pre-canned one from Hugging Face, can handle batch data, it'll do that. There's we use a like schema called like the Open Inference Protocol, something that us and Kserve and NVIDIA all use, and it's like we're trying to get more people to adopt it. So go and read about it if you're interested. But it's, again, to Andrew's point earlier around like building that kind of data contract. If you use a different inference service everywhere, right now the payloads always look slightly different, and we're trying to standardize that and come up with like an overarching spec. So that's what it uses at the front, but often you have to like decode that into your, I don't know, tensor or NumPy array or whatever it is you need underneath. Cool. All right, I think that's enough of me rambling for now. The next one of these is on the 18th of July, right? So put it in your diaries. Reminder again to come and let me know if you want to speak or reach out to me on one of these many places you can reach me. Maybe don't open an issue on MLServer. I mean, you can, but it's probably not the best way to reach me. And then, other than that, thank you all for coming. It's been really good. We've got like the room for another hour, so please stick around and have lots of conversations and eat the last few packets of crisps. Thanks very much.